What if the first evidence of life beyond Earth wasn't found on Mars or Europa, but on the last planet anyone expected, Venus? A gas that should only come from living things was found in the clouds of Venus. No penguins, no factories, no explanation. This is the story of a discovery that sent shockwaves through the scientific community, and the one thing we need to do to confirm it: go there and look. About 6 years ago, on September 14, 2020, a paper was published in the journal Nature, and it turned the scientific world upside down. This paper was about the detection of phosphine gas in the atmosphere of Venus, and the reason it caused such a firestorm can be summed up in a single sentence. This could be the first evidence of extraterrestrial life in human history. We say could be because even though research has been ongoing for years, this discovery is still very new, and it's important to stay cautious. So, let's talk about what phosphine actually is, why finding it on another planet matters, and what all of this really means. Phosphine, according to chemists, is like ammonia's evil twin. Ammonia has 1 nitrogen atom and 3 hydrogen atoms. Replace that nitrogen with phosphorus and you get phosphine. Now, here's the key point. Phosphine is a biomarker, a biological indicator. Biomarkers are natural substances produced by living organisms. In other words, phosphine is a sign of life. You can find it in the guts of animals like penguins, produced alongside microbes, or in low-oxygen environments like swamps and marshlands. Of course, it can also be produced through chemical processes in certain factories for specific industrial purposes. In fact, you have to be extremely careful when producing phosphine because it's highly toxic to life forms like us. But here's the problem. As far as we know, there are no penguins on Venus, and no factories either. That's exactly the question Professor Jane Greaves and her team at Cardiff University set out to answer. At 50 kilometers above the surface of Venus, nearly 10 times higher than what we consider the boundary of Earth's atmosphere, what is phosphine doing inside these gas clouds? In a study that has been running since 2016, the researchers tried everything they could to find a non-biological source for the phosphine. They ruled out every possibility. As of now, they believe the phosphine they detected has a biological origin. Greaves herself put it this way: throughout her entire career, she has been searching for extraterrestrial life, and now that this possibility has emerged, she is incredibly excited. But she also said something remarkable. If there is something they missed, if the source of this phosphine is non-biological, all the data is publicly available. She asked the world, "Please tell us, because we could not find it." So, how exactly did the research team detect this phosphine on Venus? They used the James Clerk Maxwell Telescope in Hawaii and the ALMA telescope array in Chile. Phosphine has a distinctive absorption line that these radio telescopes can detect at a wavelength of 1 millimeter. By analyzing the dips and peaks in these wavelengths, you can figure out exactly which molecules are creating these distinctive patterns in the radiation coming from Venus. After carefully cross-referencing data from multiple sources, the researchers are confident that the molecule they detected is phosphine. The concentration is around 10 to 20 parts per billion. That might sound tiny, but it's actually far more than there should be. Now, here's where it gets really interesting. When we talk about finding life in our solar system, Venus was never a top candidate. Compared to Earth, Venus has an atmosphere that is 96% carbon dioxide, and its surface temperature exceeds 400 degrees Celsius. Previous spacecraft sent to Venus were destroyed within minutes of reaching the surface. A Soviet probe managed to send back just a few images during those brief minutes before it was crushed. But as you move higher above Venus's hostile surface, the temperature drops significantly. The region where phosphine was found sits at a relatively mild 20 degrees Celsius. Still, the clouds in that region are incredibly dense and composed of 75 to 95% sulfuric acid. That is lethal for the cellular structures that make up life as we know it on Earth. The team's biochemist, William Baines, conducted a deep investigation into every possible non-biological source of phosphine on Venus. He examined whether volcanoes, lightning strikes, or even meteorite impacts could be producing the phosphine. His conclusion was clear. None of these sources could account for the amount of phosphine observed. Every one of those sources would need to be 10,000 times more powerful to produce that much phosphine. According to Baines, if there are microbes on Venus, they either have a biochemistry we have never encountered, or they have developed some kind of protective armor. In theory, a water-loving life form could hide inside sulfuric acid droplets, protected by some kind of chemical armor? But we are talking about bacteria that would need armor thicker than Teflon? And if that is the case, Dr. Baines asks, how would they absorb nutrients or exchange gases? That part remains a mystery. But if we are talking about a living organism, here is what its life cycle might look like. Microbes could be living in a dormant, vegetative state in the lower layers of Venus's atmosphere. Their spores could be carried upward by rising currents to the more habitable cloud layers. Once inside liquid droplets, the spores could become metabolically active. The microbes would divide, and the droplets would merge and grow. When the droplets grow large enough, they begin sinking through the atmosphere. As temperatures rise, the droplets evaporate, forcing the microbes to become spores again, waiting in the lower layers just like before. A complete cycle. And there is another piece to the puzzle. Scientists believe Venus was not always this deadly. Billions of years ago, it may have been covered in oceans. When you factor that in, the possibility of life becomes even stronger. After years of careful consideration, weighing every possibility, the researchers finally decided to publish their findings. But as I said at the beginning, this is not a paper that claims we found aliens or discovered extraterrestrial life. This is about sharing knowledge, the way science is supposed to work, making the data available to everyone, and seeing what other scientists make of it. Because there are scientists who remain skeptical about this discovery. Colin Wilson from the European Space Agency, for example, argues there is a strong chance this phosphine could be the result of some unknown chemical reaction we have not encountered before. And there are other scientists who believe that if we are looking for extraterrestrial life, the strongest candidates are still Mars or the moons of Saturn and Jupiter. Still, others point out that if this discovery does indicate some form of life, it would mean our universe is far richer with life than we ever imagined. What do you think? Could Venus really be harboring life? Or is there a simpler explanation? Let me know in the comments. So, for this incredibly exciting discovery to be fully resolved, there is one thing that needs to happen. We need to go there and look. Yes, send a spacecraft to Venus. NASA already had plans in the works. They had started designing a type of balloon that would drift through Venus's cloud layers in the 2030s. This balloon would be able to analyze the composition of atmospheric droplets and even carry a microscope to search for signs of life. So, in summary, the phosphine detected on Venus gives us the strongest evidence we have ever had. For scientists who had been focused on finding life on Mars, this was a complete surprise. This discovery may have opened an entirely new front in space exploration for every major agency. And that is what makes it so exciting. But it is equally important to remain skeptical. In the coming days, you will probably see headlines everywhere claiming life has been found in space. But that is not how science works, and you know that. It is through skepticism that we get closer to the real truth. Let's see what doors this discovery opens and what deeper investigations will reveal in the years to come. I will be following every development closely, and whenever there is a new finding, I will share it right here. Stay tuned. And as always, until next time, glad you are here. Take care.